This question is from JEE Maths 2025. Question is like this: the sum of all rational terms in the expansion of 1 plus 2 raised to the power 1 by 3 plus 3 raised to the power 1 by 2 whole raised to the power 6 is equal to question mark. This is from the multinomial theorem. Okay. Now you are already aware of the binomial theorem, which is like this. If you just want to recall that it can be written as nc0 x power n y power 0 nc1 x power n minus 1 y power 1 plus nc2 x power n minus 2 y power 2 plus dash 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 plus ncn x power 0 y power n. Altogether it has n plus 1 terms. Yes or no? Total number of terms. This already you know. Also, if you say that r plus 1th term will be ncr x power n minus r and y power r, isn't it? Which can be written as factorial n upon n minus r into factorial r into x power n minus r into y power r, isn't it? Or you can say, if I will assume n minus r as n1 and r as n2, then I can write n1 into y power n2, where n1 plus n2 is equal to n, because n1 is your n minus r, n2 is your r, which is n is equal to n, isn't it? So this is when you will extend this theorem to the multinomial, means more than, this is for two terms. Two terms are there in the bracket, okay? When you have more than three terms, then comes the concept of multinomial theorem. More than three terms, or three terms, means more than two terms. Okay, then suppose you have like this: x1 plus x2 plus x3 dash 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 plus xk is there, and it is raising to the power 3. Now what happens? With extension to the above theorem, I can write this as summation of here factorial n upon n1 into factorial n2 into dash 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 into factorial nk, because we have k terms, and x1 will raise to the power n1, x2 will raise to the power n2 dash dash dash, xn will raise to the power nk, where n1 plus n2 plus dash 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 nk will be equal to n. This is the multinomial theorem. This is what? Multinomial theorem. Okay, I'm just using it to recall the whole concept. Then we will solve this question. So let us solve this question. And here also one more thing. If you want to find out total number of terms, so its formula is like this: n plus k minus 1 c k minus 1. Okay, suppose I am taking your example. You have x plus y plus z power, suppose 6 is there. So how many terms will be there here? Total number of terms using this formula 6. K means 1, 2, 3 terms. So plus 3 minus 1, and then c and 3 minus 1. So 6, 3, 9 minus 1, 8 c, 2 terms will be there. Clear? 8 c 2 means 8 into 7 by 2. 2 4, that means 28 terms will be there. Okay, this is the way to use the formula. If somebody asks that coefficient of, in the same above problem, coefficient of x square, y 3 and z power 1. So what you will do? You will do that factorial 6 divided by factorial 2, factorial 3 into factorial 1. This will be the coefficient. Remember that this addition of all these should result in 6. This, in that case, this will be the coefficient. Okay, so you can calculate it. 6 into 5 into 4 into 3 into 2 into 1 by 2 in, sorry, 2 into 1 into 3 into 2 into 1 into 1. So 3 to 1 will be cancelled, 2 to 0 will be cancelled, 60 is the coefficient of which one? This expression. Okay, so this is the way you have to solve. Now in our question, what was our question? Our question, the expression was like this. You have this 1 plus 2 power 1 by 3 plus 3 power 1 by 2 and whole raised to the power 6, isn't it? So in here you have to find out the sum of all rational terms. This is the question. And here, from here I am starting the solution, okay, of the above question. Now the rational terms means you don't have the fractional power of any number. That term should not contain. Okay, so to remove those terms, what we need to do? We need to do that this will be given a power of 0 or 3 or 6. 0 or 3 or 6. What happens with that? 3 3s are 3 1s are cancelled, 3 2s are cancelled, so whole number power will come. Here also this should given a power as 0, 2, 4 or 6. Up to the 6 you have to give. Okay, so multiple of 2, here multiple of 3, here no restriction, 0 to 6 any power you can give. Okay, so rational term you will be obtained. Now for that, so I can just in a rough we can see that 1 can be raised to any power from 0 1 2 3 4 5 6, and 2 1 power 3 can be raised to, what are the powers can be raised to? 2 or 3 or 6, and same logic using 3 can be given 0, 2, 4 and 6. Clear? So we'll just find the combinations for 1, 2 1 power 3 and 3 1 power 2. So 1 can be given 0. So altogether you should give the power as whole number, that is the 6. 6 is your final value. Okay, when you will give all the powers, the addition should give you a 6 number, isn't it? So this will be 0. Then with 0, what can be make 6? Either you take 6 from here and 0 from here. Okay, so take it 6 from here and 0 from here, or you can take like this, 0 and last one is 6 and this one is 0. So we can take like this also, 0 0 and 6. Okay, now next we can take 1 as 1, because 1 can be given any power 1. When you are getting 1, so 5 are remaining. How will you combine 5? You can take here, see 3 and 2, you can see 3 2, so we can give it as 3 and 2. This one 3 and this is 2. No other combination is not possible for 1. Okay, so come to the 2. When you are giving 2, then we have to search for 4 powers more. 4 powers, how can we give? Either we can give 0 and 4. Any other combination is not possible. So write it. This is 0 and this is 4. Now for 3. When you are giving 3, so this can be given 3 and this can be given 0. Okay. Any other combination is possible with 3? No. So come to the 4. When you are given 4, then what can we do? This will be 0, this will be 2. So 0 and 2. This way you will get 6. Yes, any other combination is not possible. 5, 5, then 1 required, and 1 is not possible for any case. Okay, so we will not take 5. So 5 will be cancelled out. Now come to the 6. When you take 6 here, so you can take 0 and 0 from there, 0 and 0 from there, isn't it? So how many possibilities are there? Can you see it? 1, 2, 3, 4, 5, 6, and 7 possibilities are there. Then you have to find all these and add them together. Okay, so when you will do this one, what you will get? First coefficient. Your first coefficient is factorial 6. I can use this color for now. Okay, so first coefficient will be factorial 6 upon factorial 0 into factorial 6 into factorial 0 into 1 raised to the power 0 to 1 by 3 raised to the power 6 and 3 1 by 2 raised to the power 0. If you will calculate it, you will get like factorial 6 cancelled. Factorial 0 will give you 1. 1 power 0 will give you 1 into 2 1 by 3 power 6 will give you 2 1 by 3 into 6 into 3 1 by 2 power 0. Anything to the power 0 is 1. So you will get 2, this 3, 2 power 2, that is 4. Okay. Now come to the second one. This is over. Now come to the second one. In second case, factorial 6 divided by factorial 0 into factorial 0 into factorial 6 and 1 raised to the power 0 to 1 by 3 raised to the power 0 into 3 half 3 power half raised to the power 6. So in this way also 6 and 6 will get cancelled. Factorial 0 will give you 1. 1 power 0 is 1. 2 1 by 3 power 0 is 1. This will give you 3 1 by 2 into 6 2 3 are. So you are getting 3 power 3, that is 27. Now come to the, this is over. Third part will give you factorial 6 factorial 1 into factorial 3 into factorial 2 and 1 raised to the power 1 to 1 by 3 raised to the power 3 3 1 by 2 raised to the power 2, and if you will simplify it you can get like 6 into 5 into 4 by 2 into 1 into 1 into 2 1 by 3 into 3 into 3 raised to the power 1 by 2 into 2. So this way you are getting like 60 into 2 into 3, because this will give you, okay, 360. Now come, this is over. Now come to the next. This will give you factorial 6 divided by factorial 2 into factorial 0 into factorial 4 into 1 power 2 2 1 by 3 power 0 into 3 1 by 2 power 4. Okay, so this way just Just a minute. Okay. So what will be the answer for this? Here we will write 6 into 5 because factorial 4 will be out. 2 into 1, then 1 power 2 is 1. 2 1 by 3 power 0 is 1 into 3 1 by 2 into 4. 2 ja 2 3 ja. You are getting 15 into 3 power 2. That is 15 into. This is your 15 into 9. That is 135. Now which one is over? This one is over. Now you have 330. So let us see. Factorial 6 divided by factorial 3, factorial 3, factorial 0. So 1 power 3, 2 1 by 3 power 3 into 3 1 by 2 power 0. So this will give you 6 into 5 into 4 by 3 into 2 into 1 into 1 into 2 power 1 by 3 into 3 into 3. 1 by 2 power 0 is 1. So 3 to the 6. You are getting 20 into this will give you 2. That is 40. So which one is over? This one is over. Now come to this 402 and 600. So factorial 6, factorial 4, factorial 4, factorial 0 and factorial 2 into 1 raised to the power 4 into 2 1 by 3 raised to the power 0 into 3 1 by 2 raised to the power 2 is equal to 6 into 5 into 2 into 1 into 1 into 1 into 3. 1 by 2 into 2 gets cancelled. 2 3 are. So 15 into 3 45. And last one is your 600. So factorial 6 divided by 6 factorial 0 and 1 power 6. 2 1 by 3 power 0. 3 1 by 2 power 0 will give you 6 factorial cancelled and everything is 1. So total sum is, if you will see starting from the starting, first one was 4, then 27, then 360, then 135, 27, then 427, 360. 4 plus 27 plus 360 plus 135 plus 40 plus 45 plus 1. So you will add it. 4 plus 1 5 for 50 plus 40 90. So till now 90. 90 plus 360 plus 162. 27 plus 135. So you will get 2 21. So 2 and 6. 612 is your answer. Now this is looking like a big solution, but it is not like that, because when you I have made this solution like this to make you understand. Now the moment you have understood, then you can do it directly. Okay, no need to worry about that. Thank you.